he started Sea Transport Corporation. The company has sold ship designs into 47 countries. It owns and operates 3 commercial vessels and has built 2 ports. He's created in excess of 13,000 man-years of employment in various fields: ship operations, ports, designs, consultancies. He's the winner of 10 international awards for services to the marine industry, including 5 environmental awards. He's also published 3 books, with all the proceeds going to the Seamen's Mission. He tells me that he likes family, fun, boats, and ships. He dislikes anyone who doesn't bother to find out or to use their talent. But our first speaker this evening is going to be Roy Pedersen. Roy was born in Ardrossan and brought up in Aberdeen, where he graduated from Aberdeen University with an MA in Geography and Economic History. He spent most of his working life based in Inverness, where he pursued a successful career in economic, social, and cultural development with the Highlands and Islands Development and its successor, Highlands and Islands Enterprise. Early in this career, as a young transport research officer, he was the original architect of the road equivalent tariff and has subsequently studied ferry operations worldwide. More recently, he's been a proprietor of a consultancy business covering the diverse fields of transport and cultural development and has served as a Highland councillor. He's written a number of books, both fiction and non-fiction, including A History of Loch Ness with Jacobite, which was a history of cruising on Loch Ness, Who Pays the Ferryman, the Great Scottish Ferries Swindle, Western Ferries Taking on the Giants, and The Port of Inverness, a celebration of 175 years as a trust port. He writes, publishes, speaks, and broadcasts on a variety of issues connected with the history, present and future development of New Scotland. So Roy, first of all Roy, then Stuart, first of all Roy, over to you.
Right, thank you very much. That's wonderful, Robin. I'll just go on to screen share now, if I may, and if I can get this to work. Yeah, here we are. So what I'm going to talk about tonight really is alternatives to the present mode of operation of ferries in Scotland, particularly on the Clyde and Hebrides system. I suppose most of us are aware that things haven't been going terribly well in the last few years. And what I want to look at and share with you is how things are done in really 2 parts of the world. One is Norway and the other is Australia. And what can be learned from these 2 places that might be applied in Scotland to see if we can get better solutions. So I'll just go into slideshow, if I can, from the beginning, and here we go. So next slide. If we go back to 1954 and the time when the vehicle ferries of one kind or another were starting to come in I mean, the vehicle ferries have been on the go in parts of the world for a long time, in the Puget Sound since before the First World War, in British Columbia since the interwar years. But if we start about 1954, when Arran came on the scene, Arran, Bute and Cowell, we had 399 passengers and 30 cars in Norway, and a crew of around 20. I can't actually see my screen, that part of the screen at the moment, but compared with Norway, similar capacity ferry with a crew of 10. So already we're seeing a divergence in the way one country and another country run their ferries. And needless to say, the Norwegian system, it was much less costly and therefore more efficient than the Scottish system. The Norwegians really kind of cracked the theory of it in 1963 with the Møre og Romsdal county in Norway, Fylke in Norway. They did a very, very extensive and a really quite mathematical study of ferry operations, and they came to the conclusion that ferries should be part of the road system, frequent crossings, simple ships, minimal crewing, crew living ashore, lock-on type link spans, which I think I'll show in the next slide, and landing passengers over the link span as the most efficient way of handling both passengers and vehicles. Sorry, so I'll come out of that if I can. Yeah, so the lock-on link span, this is not unfamiliar in Scotland because, as we'll see in a future slide, the Shetlanders have followed this system. And instead of the ramp on the ship coming down onto a heavy link span, the link span comes down onto the ship, and then a little flap comes over basically and locks the link span onto the ship, which means the link span can rise and fall with the traffic going onto the ship, or if there's a bit of a swell, it can rise and fall with the ship. It's actually a very safe system. So, and it's a cheaper system as well, cheaper to install and operate. In Norway, we have ferries all over the place, increasingly replaced by tunnels and other fixed links, but high degree of standardization, frequent services running from early till late, shore-based crews, individual routes or small groups of routes are tendered separately. They're not all tendered at once, there's just a programme of tendering throughout the year and over the years, and open to a number of operators. 5 main operators in Norway will bid for routes. Electrics replacing diesel increasingly, and increasingly replaced by fixed links. Take longer routes like to Lofoten. Now, Lofoten Islands, north of the Arctic Circle, out in the Atlantic, really quite wild in the winter time and at times. And if you compare the Norwegian approach with the Scottish approach, Land de Gode, 390 passengers, 120 cars, 96 metres, 12 crew. In Scotland, the new Isla-class ships, similar size, less cars, 28 crew. So again, you have a productivity gain of, as far as crewing is concerned, of more than double with the Norwegian model. Another feature of the Norwegian system is fast catamarans, very often 35 knots, 3 crew, running all over the place from main coastal centres, multi-port calls, and really it's a bit like the Clyde steamer system of times past, of 70 years ago, 70, 80 years ago, when a ship would be based at a port, a railhead, and they make multiple calls. That system still exists in Norway, except it's done with fast passenger catamarans. Superb system, and they're all over the place. There's 2 of them there, and that's not taken in an urbanized area. That's taken in quite a remote area. So the Norwegian methods: short crossings, simple ships. So I've been through this already. Terminals unmanned or minimal manning. High frequency, high capacity, operating from early to late, or indeed 24/7. Greatly reduced operating costs compared with here, reduced emissions, high level of patronage because it's a good service, a convenient service, and therefore increased revenue. So that cuts down on subsidies. And the fast passenger catamarans I've already mentioned, and all of this is aimed at the economic and social well-being of the communities served. Now we go to the Antipodes, and I include this picture because catamarans have been common in Polynesia and the Pacific area for 1,000 years. When the Vikings were roving the Atlantic and reached America, so were the Polynesians roving from both in the Indian Ocean and the Pacific, roving far and wide, even further than the Vikings ever did, and on catamarans or outrigger canoes. Now, this is maybe a kind of classic case of the old way and the new way. Kangaroo Island, in the news recently because of the terrible fires, but traditionally the service was from Adelaide, the main city in South Australia, to Kingscote in Kangaroo Island, the main port, until the idea came of a short crossing from Cape Jarvis to Penneshaw. And this is where my good friend Stuart comes in, and he designed in 1984 a catamaran called Philanderer the Third, 25 cars, 250 passengers on this short crossing, which was introduced by a man called Peter March. Now we have two catamarans of the kind you can see there, 16 knots, 2 times 1 megawatt power, so not highly powered, therefore very economical, and operated by a company called Sealink. Very frequent service. It's geared to traffic. In the summertime, the two of them go back and forward a lot. In the wintertime, they use one ship and not quite so frequent. There he is, the man himself, designer extraordinaire. I won't embarrass him anymore, but you'll be able to see him in just a few minutes. Now, I suppose coming back to Scotland, the traditional, if you like, Calmac, not just Calmac, but Scottish way of doing things. We're in, the late 2000s and, about 10 approximately. Finlagan, just to give you an example, £24 million and 85 cars, 8 megawatts of power and 16.6 knots. Pentalina came on the scene, designed by Stuart, operated by Andrew Banks of Pentland Ferries, £7 million, built in Philippines, similar sort of capacity, but operated by 10 crew instead of 27, and capable of 19 knots with about half the power. So you can see the productivity gain there. Now, how would we apply these in a Scottish situation? Well, one of the studies I did for the Mull-and-Iona Ferry Committee was to look at these Norwegian methods, and the Highland Transport Board in 1967 produced a report which recommended the kind of Norwegian system, number of places in Scotland. And the one area in Scotland that went for this in a big way was Shetland Islands Council. Now, I don't know if many of you recall the Earl of Zetland used to run from Lerwick 3 times a week, up calling at the various North Isles of Shetland, and finished up in Baltasound. Next day it would come chugging back again. So not a terribly frequent service. A number of Shetlanders came up with the idea of short crossings just before the war, using small motorboats basically and bus or car connections. And the overland route was created. It was passenger only at the time. Well, the Shetland Islands Council decided, with Norwegian advice, to go for the Norwegian system and use the overland as their method of vehicle ferry provision. Very frequent crossings using the Norwegian-style link spans. Ships had a crew of 3 normally, and running from about 6 o'clock in the morning till 10 o'clock at night, or midnight at the weekend. It revolutionised access to and from the North Isles of Shetland. Now, a similar concept was suggested by the Highland Transport Board for Isla and Jura, but it was turned down by the then Scottish Office because of the expense. I don't know if that was the only reason. The expense of upgrading the road on Jura and in the mainland, and I'll come to that later. Western Ferries, however, they were the next to step in with, well, basically Norwegian methods. Sound of Jura was built in Norway based on a Norwegian ship, Smøla, that was operated by Møre og Romsdal Fylkesbåter. And at a stroke, Western Ferries halved the cost of taking vehicles to and from Islay, and provided a more frequent service. It revolutionised access to Islay. And the story of that you can read in my book, Western Ferries, but they were driven off the route basically by predatory price, highly subsidised predatory pricing. The Western Ferries system was very profitable when it was introduced. But you will all be aware that Western Ferries, of course, survived on the Clyde and provides what is by far the most used, the most they have the most patronage of any internal ferry service in Scotland. There's more traffic on the Hunter's Quay to McInroy's Point service than all the other Clyde Calmac services put together. And as you will know, crew of 4 on each of the ships. The streakers had a crew of 10. So again, you see that productivity gain, and it's highly profitable service, and very much patronised because it's so convenient. Around that time, the Pentland Firth was served by St Ola, passenger cargo ship, lift on, lift off. It left Stromness in the morning to Scrabster, went back in the evening. In those days, you couldn't get off Orkney and do business in the Scottish mainland, not by ferry anyway, and get back the same day. A number of solutions were looked at, and 2 emerged. One was to keep the St Ola system going, but with a vehicle ferry, and the other was the idea of a short, frequent crossing between somewhere near John O'Groats and the nearest point in Orkney, which is Berwick in South Ronaldsay. By this time, since the war, since South Ronaldsay was joined by a fixed link, the Churchill barriers to Orkney. So these were the 2 alternatives. And sorry, I'll go back to that. What emerged out of that was, since Pentland Ferries had a go at the short crossing, they weren't allowed into Berwick, so they operated between St Margaret's Hope and Gills Bay. Without going into the history, now that route, although it has never had a penny of public money, and the Northlink service to Scrabster gets about 10 million a year, Pentland Ferries is now carrying the majority of the commercial vehicles, cars, and passengers across the Pentland Firth. So the big change that has taken place, as most of us will be aware, is the demise of the traditional multi-port services. I won't name them all, but they're all there. It's sort of the old way of doing it. It's great, you know. We all have very happy memories of that, but it wasn't an efficient way of providing connectivity between our island communities and the mainland. Now, a partial adoption of the Norwegian principles, and the Kyle Calacan ferry was a classic example. Basically, it replaced the Portree mailboat. Was a very frequent, and it was the busiest Calmac crossing. Corran, Collintrive, Fishnish-Lachlan, and so on. Sounds of Harris and Barra. Now, I know Scottish. I pressed for this when I was with HIDB before. Took a long while to get a recognition, and the Scottish office was very reluctant to go for it, because they said hardly anybody ever travels between across the Sound of Harris or the Sound of Barra. Well, of course they didn't, because the service was so blooming infrequent. When the Sound of Harris was introduced, the Scottish office were absolutely astounded at the traffic that was generated, because it was frequent and convenient. So there we are, just a electric ferry in Iceland. The Herfjoldur, it runs on electricity most of the time. Now, I thought you might be interested in this, the making a comparison with, say, Sound of Seal or one of the almost identical Western Ferries boats, and the electro diesels, as I like to call them, Lochinvar, Hallig, and Katrina. Cost, first of all, the electric boats cost 3 times as much, and they carry about half as many cars. They're slower, and they consume more diesel per car space per hour than the Western Ferries boats. Now, it seems to me quite astonishing that a system that is supposedly more environmentally friendly is actually less environmentally friendly than the Western Ferries system. So there's a pause for thought. Both ships were built in the same year. Another kind of odd thing, the Utne, which operated in Norway, was purchased by Seamal for operation in Mull. Crew 4 in Norway, no shore staff. So the total number of folk required to operate that service was 4. In Scotland, she was converted for Scottish conditions. The crew went up to 7, and the number of personnel increased exponentially. So why is it that in Norway they can do it with 4, and in Scotland it takes several times as many to operate the same ship? Sort of question, discuss. Aaron, when Seamal was looking at how to replace the Caledonian Isles and other ships on the Ardrossan Arn service, they looked at a number of options, of which a catamaran was one. On the left, you'll see the design that was produced by Stewart. It would have cost £15 million if built in the Far East, speed of 17 knots, under 4 megawatts of power, and 98 cars. Compare with Glen Sannox, which was to have cost about just under 50 million, is now going to cost over 150 million, with more power, less speed, and much the same capacity, a little more capacity, but requiring 34 crew instead of 14 crew. So, guess which one Seamal went for. It's astonishing. It's interesting to see how Alfred is faring on the Ardrossan Arn route. But certainly, as regards value for money, you've got one ship that is one possibility that is 1/10 the capital cost of the other, and less than half the operating costs, and probably a more reliable vessel, because she's got less windage than the high monohull that is proposed for the route. For Mull, I did a bit of work for the Mull and Iona Ferry Committee. What we came up with was 2 catamarans, 17 knots, instead of the present system, which you'll be familiar with. And this was the schedule. Until Loch Risa came in, on certain days of the week, it wasn't the first arrival in Oban in wintertime was 12 o'clock. And on those days, the last boat out of Oban was 4 o'clock. So you couldn't even get to the hospital for an appointment and back in the same day. What is proposed by myself and the Mull and Iona Ferry Committee is 2 catamarans, hourly service in the summer from 6 o'clock in the morning till 8 o'clock at night, or indeed 10 o'clock at the weekends, and a 2-hourly service with one vessel in the winter time. Would double capacity, and it could be provided at less cost to the public purse and would generate more revenue. Again, the Isla Overland, if that were instituted, the savings in CO2 would be absolutely enormous, and the capacity would be increased. The frequency of service would be much greater. Could basically go almost any time you want, from early in the morning till late in the evening, and it would cost far less. Now, the issue that's always been the bugbear is the state of the road on Jura. And that on the left is the sort of main bit of the road. The bit to Craighouse is better than that, but beyond it gets kind of increasingly worse. And then the last mile down to the pier is really, really pretty bad. But if you look at the cost of upgrading that road, compared with the 25-year cost of two large ferries with about 6 megawatts of power and 27 crew and so on, then you can get an awful lot of road for that money. So in the long run, it would both be cheaper and, of course, a far better solution. It would be possible to run a bus from Port Ellen over the two ferries and into Glasgow several times a day. So that's the kind of Norwegian system. So without time's wearing on, without taking up too much time, that's the 25-year, the difference in 25-year costs. Other possibilities of using the land bridge, call Tyree, upgrade the road to Tobermory, much, much more frequent service. And it would be possible to get from either Barra and Tyree to Oban, do business in Oban, and get back the same day. Not possible now. Much more capacity and a cheaper way of running the service. This is just an idea that I sent a letter to the Shetland Times. I don't know what the reaction is, but it's not possible to get from Shetland to anywhere in mainland Scotland in daylight. This is one way of doing it. A ship leaving the south end of Shetland for Kirkwall and back in the same day. It would then be possible to get from Shetland to, say, Edinburgh in daylight in the summertime with one vessel instead of two. And the type of vessel I have suggested is the Lofoten type of vessel. So there we are. The sorts of improvements that could be made: Isla Jura, Colonsay with 40-car catamarans, Arran, 3 catamarans, 3 98-car catamarans, 2 for Mull, 2 for Bute, slightly smaller, Barra, Tyree. Split the Uig, Tarbert and Vegan, which I have been arguing for about 20 years as 2 separate routes. Type of ship vessel to be discussed, but no reason why catamarans could not be used. Orkney North Isles needs replacement. That could be done with catamarans, and so on. Road improvements are required and new terminals to make that system work. And just more or less finally, fast passenger operations. Sound de Mull would seem an obvious one. Perhaps a Malig, Kyle, Portree fast catamaran. That's basically reintroducing the Portree mailboat system, but instead of having a crew of 20 odd, you have a crew of 3 or 4. Now, here's a thought for you, the Royal Route. I thought I would provide a nice picture. That's the Chevalier. Not many colour pictures of Chevalier, but I've got one. And that's it. So in the old days, that was the Royal Route was the prestige route. Why not reintroduce it using fast passenger catamarans? 22 knot service speed, say, because in that way you wouldn't need to be seated all the time, say 260 passengers, 4 crew, something like that. Now, as Stuart has indicated, loadings, at what point does that become profitable? Now, I don't really know. I haven't done a business case on it. Would it be viable? I don't know. But I would have thought it would be a very attractive proposition. I've suggested Weems Bay as the start point rather than Gourock, because Weems Bay is an attractive station. But that's just my thought. Save a bit of the steaming time as well. So, glory days once more. This is what I would suggest: more connections, more efficient ships, more capacity, less emissions, less subsidy, more prosperous, vibrant island communities. What's not to like? So finish with a picture of Jeannie Deans, and thank you and enjoy wonderful sailing, shipmates, members of the Clyde River Steamer Club. Thank you very much.
Okay.
Thanks, Roy. Really enjoyed that. Stuart, over to you.
Okay, you ready?
Yep.
Okay. So that when I first came to the Gold Coast, we didn't have a seaway, so we only had a bar port here, and of course, lots of people used to get killed on it. But the people that got killed were always on monohulls. So we designed, it was actually a pal of mine who started the Shark Cat as the unsinkable trailerable catamaran. And as you saw in that little video clip, the cats even could take a cascading wave. So in 76 onwards, I was the designer of Shark Cat, Kevlar Cat, Cougar Cat, Manta Cat, and over 5,000 of them built. As you can see, they started to become much bigger. 1982, I tank tested this in Strathclyde University, and we were playing around with symmetric hulls with no parallel mid-body, asymmetric hulls with no parallel mid-body. We tried hull spacing, hull angling, bulbs, and with this particular vessel with 250 horsepower, with 300 each side, with 320 passengers, we got 14.5 service speed. And other designers, watching us down in Sydney did the exact same length, beam, and draft, and only managed 10 knots. And this particular vessel repaid itself in about 8 months. Then, and from, as you saw, we did the study for Kangaroo Island, and as Roy indicated before, do the short route joining the two roads. We did the study in 1982 and 84. I put this vessel in, and it changed from the long run with 3 trips a week with 28 crew on the government ferry to this one was 10 crossings a day. And what it did, it re-energized the island tourism, reopened the abattoirs and other businesses, and eliminated the government subsidy of 10 million per year. So we were the ones that set up the clearances of the bow, of the throat, and the stern. This is 1985. It's now become a class rule. Just going back to some simple things like landing barges and some monohulls, simple like rectangular midship section. You got a 13-ton axle loading all right across these ferries, but they don't have sufficient stability to carry the trucks all over the deck. You can only carry maybe 1 or 2 lanes of trucks, but you can't certainly carry it over. So what we did is, being simple, stupid sailors, we just did the axle loading on the section of the vessel, the midship section of the vessel here, 13-ton, whereas the rest we did 1.5. So the payload then went from 30% of light ship, went up to 90% of light ship, and sufficient stability to carry trucks and cars in the other lanes. So to take this to a practical thing, we bought a little ferry company in 1990, a little thing called Islands Transport, with 3 ancient landing barges. So we started designing and building of these replacements. So 1991, I did this 35-meter vessel. The reason why we stick to 35 and 50 and 75 in Australia, was the manning. They were the manning jump points. So we put this monohull on, and we got 27 cars at 8.5 knots, and it was capable of working into bow or stern concrete gradient ramps. But 1 year later, we did another 35-meter vessel that carried 35 cars at a much faster speed. So the southern Moreton Bay Island routes, which was 4 islands, we could do much more trips with 30% more capacity. So the bottom vessel there was 65% more viable than the one on the top, even though we owned the 2 of them. And the second thing is that the skippers didn't like handling the monohull because they were tougher to handle, whereas a quad screw catamaran was much easier to handle. Gentlemen's boats, they called them. So then we designed some of them with scarf bulbs to get into the gradient ramps, as you see down in the bottom picture there. And then we decided, okay, we'll take the weight and the mechanics of the ramps off the ferry to the standard floating ramp. And these were ramps for normally our ferries from 50 to 80 meters. And the ramp hinge point, very similar to what Roy had described before. You can see it just comes on here and the little bulwark actually locks it in place. And the ramp hinge point must be at the mean sea level plus freeboard at mid displacement. So it really is, so it minimizes the angle change. So the floating link span dead load and live load is carried by the ship while connected. So on the end view, this is what it looks like. And the reason why we made it 8 meters wide is that we can take on things like bulldozers or farm equipment around South Australia, where we operate a ferry at the moment. We're carrying farm equipment all the time with what they call these big spreaders, which are probably 7.5 meters wide. So we can take those sort of things on board there. And this is actually quite a successful one. So we also did some smaller vessels. These are the Crusader. This was a boat that I built for myself, but we tank tested this and we optimized the bow form. We optimized the center of buoyancy to center of flotation, separation, and location. We optimized the longitudinal pitch radius of gyration, which if you speak to most boat builders, they won't know what you're talking about, but it's actually worth putting the money into research. And at the end of it, for this little 60-footer, we only needed 462 kilowatts, which was less than half of the same length, same displacement monohulls, the standard production Riviera, Bertram, Maritimos, that they knock out for probably $5-6 million. So then tank testing, this is where we tank tested the Pentalina. And of course, we had to do up to 5-meter waves, but we did a lot of work on bulb research programs in 1979. We tested cylindrical, elliptical, and pear-shaped bulbs on trawlers. And according to the Naval Architecture 101, at that stage, bulbs didn't work on ships less than 8-to-1 length to beam ratio. In other words, it would only work on a big skinny ship, a big skinny monohull to that. So we started testing different things, and we started getting some very good results. And you can see with the Pentalina, when we tank tested that, we ended up with was about 4 or 5 different bow shapes that we tested for the waves in the Pentland Firth. And this is the one that we came up with, and of course it worked very well. Now, the outcome was we reduced the pitching motions, we reduced the heave motions, we reduced the average motion resistance, which will vary between 8 and 30%, depending on the wave and counter frequencies. As you guys know, sometimes you get short, steep waves, sometimes you get long waves, but sometimes a combination. We reduced the seasickness, and of course, as you know, the Pentalina won the Scottish Transport Awards in November 2010. We still keep doing that sort of stuff. Now, this is one we did for a German company running between Spain and Algeciras in Morocco. And they wanted to go from really fast vessel just back to 18 knots. And so we did a series of testing for these 90-meter cats. And at each stage of the testing, they give you a green dot. Now, this green dot here, if you take, they show all of the previous ferries tested, but they don't tell you who's who. But if you take the mean line and the difference between the green dot, this is a fuel advantage of 620,000 liters per annum for 4,000 hours of trading. So the Germans didn't want to pay the money for the tank testing, but when they saw these results, they said, "Oh, this is terrific." And we do a lot of tank testing. We're probably the biggest user of the Australian Maritime College tank test facility, and it's one of the reasons why we stay ahead of the curve. Environmental aspects, we do solar arrays, which we've done for probably the last 15 years on the flybridge for the comms and the wheelhouse air conditioning. We always aerofoil the lower bridge front to reduce the resistance. We can save 55 kilowatts on that. And people say, "Oh, the rule book says you're supposed to be able to stand in the wheelhouse and look out. I keep saying to them, look, in the airline industry, the captain of the plane doesn't stand in the cockpit. He sits in the cockpit, right? And just nonsense. We have rain harvesting scuppers aft, port and starboard. We optimize the shape, as you know, for the resistances and emissions. We've done catamaran tugs, and that little exercise you see in that, it was an exercise for the Orinoco River in Venezuela, where they were pushing with a monohull tug with a 4.5-meter draft, a 7,000-ton barge. And they came to us and said, well, look, the trouble is that we can't get back over the bar. Once we've taken the barge out and loaded to the ship, when we go back into the river entrance, we have to wait till the tide comes up so that the 4.5-meter tug can actually get across the bar. Can you give us a cat tug with much less draft? So we did that. And we pushed a 15,000-ton barge at a higher speed. So catamarans and other roles, hydrographic vessels, these are 5 vessels that we did for the Indian Navy. It's exactly the same hull as a 56-meter one that's down in South Australia, 56-meter ferry. So it's just painted a different color, and the price has been doubled, as they usually are for Navy vessels, are trebled. And we did 4 hydrographic vessels for the Royal Australian Navy. Now, one of the things that we've always done is that we've adopted an airline strategy, and we always try to do a single side berthing for permanent route vessels. And what that does, we can reduce, it simplifies the fueling arrangement, the shore power, the gangways, the mooring equipment predominantly on one side, and it reduces the capex and opex. And a lot of people say, operators say, oh, no, we need to berth both sides too. And I always ask them, when have you ever come on or off an airplane on the starboard side? And they go, oh, yeah, that's a thought. Never thought about that. So then we got involved in closed cell foam, class-approved closed cell foam for the last 5 years, probably over 5 years now. We were working with Strathclyde University and another company in Poland for class-approved foam. So if the bulbs are damaged, there will be no water ingress in the forepeaks. There'll be no trim by the head. There's no need for the collision bulkhead to come higher than D plus 0.5 D. There's no need for the collision bulkhead to remain between certain sizes. A lot of the old rules, actually, when you say to them, well, who says that? And they said, oh, it's always been that way, Anyway, so the risk control options, if we put foam, most ferries have a survivability index of 0.7, which means that they can survive 70 out of 100 disaster scenarios. But if I foam that forepeak there, I can take it to 0.76. If I foam fill the aft peak, I take it to 0.83. If I put it under the tank top, I can take it up to 0.93. And then I can take away all those bulkheads in the lower deck, as there used to be in the old ferries before there was too many capsizes and sinkings. And if I do across the bridge structure, I can take it to 1, which means it's unsinkable. So this is the survivability index. You'll hear more and more about that in the coming years. And but it makes that lower tank top usable. Now, this is what happens with a ferry where the master is asleep at 2 o'clock in the morning and you run into a rock. This is one of our 50-meter vessels in the Bahamas, ran into the rock, damaging both bulbs. And they did get water ingress into the forepeak. The trim of the vessel went down by 800 by the bow. It raised the stern up by 700. It exposed the props of the 4 propellers and 2 rudders. And luckily, to relatively benign weather conditions at the time and mid-load condition of the vessel, she managed to froth her way back to Nassau. So we investigated the advantages of filling the forepeak with the closed cell foam, as I showed you before. So if I take the midship section and I fill in the tank top with the foam, I'm up to 0.93, as I showed you in the longitudinal section. If I fill this one, it brings it up to 0.1. She's then unsinkable, but I can take that upper deck, the upper mezzanine car deck, down to below. if I've got the vessel unsinkable, and I can reduce the whole superstructure like this. So it reduces the windage, but it makes use of the space on down below the vessel. The capital cost of the vessel is less, and the vessel is unsinkable. How good is that? Now, future developments, what we're doing at the moment, we looked at bow thrust. Now, bow thrust on most vessels will increase the resistance. A normal bow thrust tunnel will increase the resistance that will cause 0.5 or 0.7 of a knot reduction. Well, now what we've done, we thought, well, hang on, if we actually put an azimuthing bow thrust and change the whole tunnel shape of the bow thrust, maybe we could use this as a pull propeller and a dynamic position. So in other words, this one, when I come alongside, it acts as a normal one, but as I'm leaving, I can actually pull the vessel away or pull it on an angle. Depends on the wind condition. And I'm first and foremost a seafarer, so I always like ships to handle easily. So we then said, okay, well, it sounds good in theory, and we did some computer fluid dynamics analysis, but then there's nothing better than going tank testing. So we tank tested this year with these systems, and it worked out very successful. And so we're now looking at azipods, which a lot of people now, and the big ships, as you guys are all cruise junkies, that you'll know that they handle the big cruise ships only have 2 or 3 of these azipods, and they're generally pull propellers. Now, this is me standing beside a 400 kilowatt one. Now, what we've taken that system, because there's not many producers of very small units that have made the market, and we actually have a Dutch company in Batam near the shipyard that we're using that actually produces these things, so it's fantastic. So this is one of our new vessels that we're proposing. And then we took it to a step further and said, okay, well, let's put it in a floating chamber so that when we need to replace it, we actually can float it out of the side of the ship. Now, this might not sound very interesting for people in Scotland where you've got lots of slipways, but in Samoa, where the nearest slipway is several hundred miles away in Fiji, this is very valuable for them, because if they clip a reef or a part of an outcrop of a coral, that's them out of business. So what we've developed is that we can actually plug these in, and the cables, there's 4 cables, the thickness of your fingers, that in the connection at the top of this chamber, just as a plug and play. We call it the hot swap. So if I do like this, so if you bought one of our new vessels, we would suggest that you buy one of these extra units so that you can hot swap in case of any damage. So what we're now doing with our new 65 meter ones is the basic arrangement is 2 steerable pods like this. And it gives me 13.5 with those 500 kilowatt units. But if the owner wants more than 13.5, we say, all right, well, look, we'll put 2 fixed pods on the inside and exactly the same size chambers that we can float in from each side, and that'll give me 15.2 knots. If I do another 2, it'll give me 17.8 knots. So, because one of the things that we get with different clients, some clients just had happy at 14 knots, so some clients want 16, some clients want 18. So this is a plug and play, looks after all clients. Now this is actually a passenger cargo vessel, but it's in military colors. And this was, this is showing some of the stuff that we're working on. Now we're working with the Canadians on a 5 megawatt micro modular reactor, an MMR, and sticking on one of our SLV designs. We do monohulls, as you saw in the earlier, one of the earlier slides. The stern landing vessels that we produced can back into a rampway, and it can a concrete rampway, and it can back into a beach. And if you go into our website, you'll see the military versions of this. But what happens in the disaster response, for instance, in the South Pacific, if they get a cyclone or a tsunami, and one country has several hundred people stuck on a beach, they have to telephone Australia and New Zealand to scratch their backsides for 3 days, and then they'll send the biggest Navy ship they can find that can only anchor 3 miles off the shore, send some helicopters and some ribs and try and help them. And what the Fijians want to do in particular, they want to have their own passenger cargo ships that will do regional servicing. But with this modular reactor, we can actually supply this will run this ship for 8 to 10 years without refueling. But then when it's alongside, it can pump 4.5 megawatts into the electric grid system when it's alongside. And if it's doing disaster relief, it can just plug ashore, because one of the first things that happens in cyclones and tsunamis is that the power goes out because the trees and the telegraph poles and everything is fall over. So Samoa, Tonga, Futuna, Vanuatu, Solomons are all within 2 days steaming of Fiji. So remote islands such as Rotuma are scheduled patrols with cargo passengers. We operate this with defense, or we're proposing operating this with defense personnel, because they can get around the rules and regulations that normal ferries. If I operate a ferry, say, from one of these countries, you come under then the IMO rules and the SOLAS total rule book, then you've got to have lifeboats and all the rest of it. The defense, we can actually do it much more sensibly. So, for instance, if I put this nuclear powered vessel at the center of Fiji, we're helping Fiji restore their shipbuilding and their domestic fleet at the moment. And so you can see that we can get to these other places very promptly. So the farthest away was 44 hours up to Samoa. You know, that's for disaster responses, excellent. So that's what we do. So that gives you a fair idea of the stuff that we're messing around with. So I'm happy to take questions.
Thank you very much indeed, Stuart. That was a fabulous talk. Thank you also to Roy. We tend to concentrate on the past, and I think there we've seen perhaps the future. And I really enjoyed that presentation. Chapesses, I hope you enjoyed that presentation.